I talk about this technique in my book of integrals, and it looks like this. So if you have the same parameter in negative a and a, and then you have the top function, which is going to be even, and then at the bottom, this particular function here is going to satisfy the condition k of x times k to the negative x is equal to 1, then this is equal to 1/2 integral from negative a to a of simply just the top function. Yes, there's a dx missing right here, but that was a typo. This is the first edition. Okay, so here we go. Let's see if this satisfies the SE1 method. Well, it looks like we do have the same parameters, negative pi to pi. That's perfect. Is the top function even? And in this case, it is, because if you were to do negative x squared cosine of negative x, well, negative x squared is just x squared, and then cosine of x is even by default, so this is just going to be cosine of x. So we get the same function, therefore the top is even. This condition, e to the x times e to the negative x has to equal to 1. Well, if we were to add the exponents, this is e to 0, which is 1. Perfect. So that means that this particular integral is just going to be 1/2 integral from negative pi to pi of x squared cosine of x dx. We have x squared cosine x. So it's basically integration by parts, but we're going to go ahead and use the tic-tac-toe method. Because this particular function right here, if you were to take the derivative of it all the way down until you get to 0, it ends. This is perfect. And now we're going to take cosine of x, and then we're going to go ahead and take the integral. So this is going to be sine of x, and then we get negative cosine of x, and then we get negative sine of x. And then for the tic-tac-toe method, we need to put a plus, minus, just alternating all the way around. And here's what the tic-tac-toe portion plays. This right here, the integral of this is going to be tic-tac-toe. There it is. So we have the 1/2, and then we're going to take positive x squared times sine x, so x squared sine x, and then minus 2x times negative cosine x, giving us a positive 2x cosine x, and then we have a positive 2 minus sine x, so minus 2 sine x, and then we still have to implement the first fundamental theorem of calculus. Now, one thing to notice, if you were to plug in pi into the sine of x, you're going to get 0 all the time. You're going to get 0 for this one too. Same thing would happen if you plug in negative pi. If you plug in sine of negative pi, you're going to get 0. So these are just basically going to be 0 by default. So we're just going to focus on this one right here. So the one thing we have is 1/2. We have 2 pi times cosine of pi. Now cosine of pi is -1, so we just have -1 minus, and now we're going to have 2 times negative pi, so 2 times negative pi, and then cosine of negative pi, that's also -1, so we have -1 here. Let's go ahead and start simplifying this. We have 1/2, this will be -2 pi, and then this is -2 times negative pi times -1, giving us a -2 pi. So our answer is just going to be -2 pi, and that's how we solve this particular integral using the SE1 method and then the tic-tac-toe.